Okay, start. Just start. Hi everyone. This is Adarsh Pathak and my friend Shiv Prakash. In this presentation, we will tell about generative adversarial networks. So this presentation is mainly divided in five parts. These are the following. First one is the base paper. Second one is introduction of a generative adversarial network. Third part is the real-time examples of generative adversarial network. Fourth part of the gener- generative adversarial future work in this model. Last one is the references. So now this is the base paper of the generative adversarial network. Basically, in this paper has proposed a new two neural network model. First one is generator and second one is the discriminator. This will work simultaneously and generates the figures. This paper generate uh, basically generates the images, which is this is just like a generative model can through a of as analogous to a team of counterfeiters trying to produce a fake currency and use it without detection, while the discriminator model is analogous to the police trying to detect the counterfeit currency. Both teams try to improve their methods until the counterfeiters and indiscriminability form between the maintenance. So further, next slide. The basic is the basic of generative adversarial network is this is a neural network architecture, and the brief history about this is it is invented by INJ Goodfellow and with his college guy in June 2014. Generative adversarial modeling involves a model to generate new examples that plausible comes from an existing distribution of samples, such as generating new photographs that are similar but specific different from the data set of existing photographs. A GAN is a generative model which have two neural network model. One is generator and other one is the discriminator. Generator generates the fake images and the discriminator discriminate these fake images from the real data. So now next in this slide, the components of GAN will be described by my friend Shiv. So please, Shiv, explain this slide. Hello, Shiv.
Okay, yes. In this PPT, we will discuss about component of GANs. And GANs divide into two parts. First is generator and second is discriminator. If we will see about generator, it is a unsupervised learning approach. That discriminator is a supervised learning approach. I will tell you in simple terms. This would be a classifier. It will be do classification and predict whether the data is real or fake. Generator generates the data. Generator generates the data. So the data would be fake because it is an unsupervised learning approach. So what it will do, I have some image or number of images or collection of images, and basis of some samples it will create some noise, and it would be a random noise. The generator is a uh, neural network. It would be having a number of neurons, layers, hidden layers, and input output layer. Here I have covered into a block, so don't confuse what would be the generator. It would be a simple or basic neural network. Here we would be here would be having the theta g, that would be weight of generator. It could be having a number of weights. On the basis of noise, it will generate some data that would be fake data. This fake data goes into discriminator, and the discriminator already trained on real data. It knows what is real data and what is fake data. So here my fake data would be having some images. Suppose I have a collection of dog images. In this collection, sorry, I suppose I have a collection of dog images. So in the uh, fake images, in the data goes into discriminator. The data discriminates already trained on real data, and it would knows what is real data and what is fake data. So suppose I have a collection of dog images in this network, so it will generate some images. So it would be like looks like dogs. So discriminator predict this is not a dog because I know how dogs look like. It has a collection of real images, and discriminator has already trained on real data. So it will predict you have not provided me a dog image. It is not a real image of dog. It is fake image. So on the so in the case of real image, it will show me true, and in the case of fake, it will show me false. So on the basis of that output, it will provide some feedback, or we can say backward propagation to go generator. Obviously, it will uh, provide the feedback to discriminator as well, but it will provide some feedback to generator. And on the basis of that feedback, how images generator will generate a new image, because main purpose of generator is make discriminator to fool, because we have to generate image that would looks like a real image. So it will again some image. Discriminator will predict again whether the image is a real or fake. So it will take number of iterations. So basically, generator and discriminator would work on competitive way to improve themselves. And discriminator terminate tiny difference between real and generated image. Generator will generate image each time that it will expected. Discriminator cannot tell difference. This is a GAN model, and this will eventually converge the and produce natural looks image. So once discriminator is fooled, so our training is completed, because that time at that time we can say that generator is creating is a similar image. I will be exploring again in next slide. So next slide, please, others. here uh, it is a little example of the random noise. This is a random noise, and the data point are here and there. So when I am feeding random noise it in generator, it creates an image. Suppose it look like 8, and here I have training set. Here I have training set. So uh, or it suppose it would be like a amnesty data set. So these are the real images, and I have created a fake image which is generated by using a generator, and I am feeding into discriminator. Now I want to uh, I want to the discriminator should predict the real image in the starting. It would be like random noise, so discriminator will predict phase fake. So that case it will generate some feedback and it will hit into generator. So after time a new image would be like different. So it will goes again to this network and it will predict it again. It is the fake, so it will generate again feedback and hit into the discriminator. So uh, please next slide others please. So here we will see a training of GAN, how we can train our data, our model. So now it about how we do train of GAN. So it's completed into 6 steps. First of all, we have to define a problem, what we want to create and whether we want to create image like video, whether we want to create video, image, voice, music, like it is a problem statement. Then we have to select in next step, select architecture of GAN. So we would be select our perfect architecture of GAN in this step. And in third step, third point, the actual training is started. We have to train our discriminator on real data. So that is our classifier, or that is our adversarial. So we have to train on in real data, so that it can store probability distribution of our real data, or uh, what is fake data, that it train on uh, at that time of training discriminator we have to freeze the generator. Discriminator freeze the generator, and which means the training set of generator is turned as a false. Or in fourth step others, in fourth step uh, we will go uh, please for okay. In fourth step we will train our uh, we will pass our fake data or noise in our generator. So our generator generate an image or fake data. Then we will pass our generator's output or fake image in our discriminator. So our discriminator again discriminator again train our uh, on fake data. So it will provide a output data is real or not. So again it will feed on uh, uh, if data is fake, then again it then we, our output gives a feedback to generator. So this process would be goes into like train generator, and our output will be mm, so what is our data is fake or real. So others, next slide please. Okay, here we will see our loss function, how work our GAN in backside of model. Here is our GAN loss function. This is a loss function, or we can say as a value function. So it's look like a minimax game. So what is a minimax game? One will try to minimize and other will try to maximize. Here generator will try to minimize this to this loss function, and discriminator will try to maximize to loss function, and it's like a minimax game. Here p data, that means our real data of of first part of loss function, and second part is fake data of in loss function. If you look like closely to this loss function, it will be look like a binary cross entropy. So it has a combination of real or generated data, or real or fake data. If you will see, like this is a x, here x, which is my real data, and from the real data I have generated a probability distribution function of a real data. Here is called a p data, and here is my z, which is noise. And basis of noise, I have a probability distribution function of the noise is p of z. Here I have a d function, or sorry, discriminator function. Basically, my discriminator would be d would be discriminator, and in this I will feed x. Here is my x. Here is my d would be discriminator, and in first part of loss function, and I will feed x into the discriminator, or because first I have to train my data, my discriminator on real data. So it would be a log of d of x, and uh, in this second part, it would be a log of log of 1 minus d of g of z. So this is my d, and in this I am using generator of z, hello, expected value of z. So what is z of z? Here z is my generator, and in this I provide random noise z, and what I have do I have to do I have feed this generated data into the discriminator, and I have to predict opposite. I have to predict one also. I don't want to predict that my discriminator predict zero. So that's why I am using here uh, 1 minus d g of z. So if you will see know about the binary cross entropy function, so it would like look like this, y plus log of 1 minus y. So it's pretty same, and this is my expected value, and what generator can directly affected to log of d of x, because it's real data. So our GAN, our generator will do, it will minimize log of 1 minus d of g of z. If this is a minimize, our data would real data, and this function is very useful. So in next slide, we will train our discriminator. So others, please go to next slide. Here we will train our discriminator. We have trained separately D and Z, discriminator or generator. So I will show you. You will train discriminator. First, we have to take a mini batch of some examples, some mini batch of some samples from the real data or P data. That means real data, and we have to update D. Here we take some sample of mini batch, sample of mini batch of noise, and we have take some sample of noise or some sample of mini batch, like real data. So in third part we will update our D. So what we will do in the in discriminator network, we would be having theta D. So it is a weight in generator, sorry, gradient descent. We have already seen that to update the weight, that we have to update this function. In this function, first theta would be here. First theta would be the new weight, and second would be old weight, and lambda is the learning rate, and del of j is the gradient of our loss function, or derivative of our loss function, derivative of our load function. Here I am dividing m because I am taking m samples, and j is my loss function. And here in the case of d discriminator, I am taking log of d of x, as well as well we will derivative, it will be 0. It will be 0, and similarly we have to sorry. And here in the case of discriminator, in the case of discriminator, I am taking log of d of x, as will we will derivate it, will be 0. So all effect would be goes on log of 1 minus d of g of z, or second part of loss function. Others, please next slide. Next slide, we will train our generator. Here we will train our generator. Similarly, we have to train generator. So in case of generator, we will only use noise data, because noise batch of sample of mini batch of noise data, because discriminator will feed both data, but generator, in case of generator, we will feed only noise data. And weight of g updates, weight of generator, it would be update same like discriminator. Here our theta z, and in discriminator our weight is theta d, and here we will update our z, and in discriminator we will update our d. So how update theta z, our g? Here is a first theta g is a new weight of generator, and second theta g is a old weight of generator, and lambda is a learning rate, and del of z is a derivative of loss function. And here m is a here we will take m because we will take m samples of noise. So in from the next slide, my friend was uh, continue. So others, please continue.
Thank you for providing this opportunity. Thank you, Suprakash. So Here, I will tell about some applications of GAN. GAN is very useful neural network model which have a lot of real-time examples and applications. Some of them are following. So first one, these images are generated by the GAN. Is basically in this these images are uh, the images of the celebrities images in which these images mm, input data has been taken from the celebrities images, and with the help of games these images are generated. These are these images are uh, approx similar to the celebrities but not same. These have some specific difference from the celebrities images. These are so real that we cannot identify that these are the fake images or real images. So this is a good achievement of GAN, which is generate a very obvious images which generally we cannot identify that these are fake or real. And in the and other examples of the GAN is image to image translation, which have these which have many examples, just like translation of sketch to color photograph. This first one image is the sketched image of a bag, which is converted with the help of GAN into the colored image. Another example of this is just like this is a hand sketched shoes image which is converted colorful image with the help of GAN. This is this image is so real just like is this is captured by camera. And in and other examples of in this series of GAN is the generate cartoon characters. The generation of cartoon images is also helpful again. And further are some examples of GAN which is generated by another. Some examples of image to image translations are here following. First one image. This is the satellite view of image which is taken by satellite. With the help of generative adversarial network, it is converted into the Google Map photographs. Another example is the image to image translation is the this is the following image. This first one image shows the summer image. In this image, trees are dry, and with the help of GAN, these images are converted into the winter images. Here, images are colorful, these trees are green, and there are many lot of examples which examples and application which in which is used GAN. GAN another example of the GAN is face frontal view of generation. In this model, again convert this picture. This man is this photograph of this man is side view. With the help of again he generate the front view. These are also similar images with same model. And other examples of this GAN is the generative new human poses. With the help of GAN, we can generate new poses of the images. In this image, this girl was standing in front view, and with the help of GAN, we provide some instructions of GAN through which pose we want. So in this image, this girl's face is front side, and remaining part is the side view. So in this way, GAN also in this way, GAN also convert front size view to new size view. Another example of this girls also, this is the front and with the help of GAN, it is converted into the back pose. Uh, from this series, some examples are like here. Uh, with the help of GAN, we convert photo to emoji. These are the examples of photo to emoji. This is a real image which has taken a person. This is converted with the help of GAN into the emoji. These are also same examples. Another examples on this series of applications of GAN is a photograph editing. This is also a very useful application of GAN. This first one is the real image of this woman, which with the help of GAN we converted into the desired uh, desired applications. This image is converted in fair color. This image having real image having black colors, while this image having fair color of the hairs. And this image is converted is have the in bunks which has sharp noise. And other in this series real image to generative image. This image have a smiley image. And last one in this shows in this presentation image is this woman picture has been converted with the help of GAN into the male image. GAN here another example of GAN is a photo blending. Photo blending is a very useful, very good and useful application in which we can merge two images which has different objects, and we can merge and generate a new picture which has a combination of these objects. So this is the first picture which having the green field, and these are the trees in this picture. And second one image, this picture have mountains and some trees also. This is just like summer picture, and this picture is just like a winter greenery picture. So with the help of GAN, we take first from the first image some samples in the rectangular form, and over and overwrite in the second image, and in the in third C portion, we take from the first image this area of the first image and superimpose into the second impose. And finally this image is generated which having from the first image this green field, and the from the second image this mountain. In this way, with the help of GAN, we can generate a combination objects of image. This is very useful in generation of different types of images. So further I will explain the future work on this model. The future of GAN, generative adversarial network, is bright. There are several areas in which I think it is likely that GANs will be used in near future. Some of these areas are like following: creating infographic from text. Infographic is a new word, so I will want something about infographics. Infographics is basically a graphic visual representation of information data so that we can understand these information clearly. And quickly. And another future work of these models are generating website designs, compressing data, drug discovery and development, generating text, generating music. Presently, generating audio are possible with the help of GAN, but in a very little time, with the help of GAN, we can also generate a music which is very interesting to listening. And in further slide, we have shown some references where I we have collect the data and make this presentation. So thank you all